I just did look at it. It looks like it's a lot of systems of equations from word problems where you're going to read it, set it up, and then you can either, if it's two variables, two equations, you could use substitution, elimination, or graphing, or you could use matrices, right, and get it in reduced row echelon form. Even if it's two variables, two equations, it works then. Or especially if it's three variables, three equations, that's going to be the easiest way to do it. And so it tells us solve the problems using a TI-84 if that's possible. So again, when I work these problems, I'm always trying to identify what the variables are at the very beginning. So the admission fee at an amusement park is $250 for kids, $580 for adults. Way cheaper than Universal. On a certain day, 268 people entered the park, and the admission fee collected was $1,198. How many children and how many adults were admitted? So right there's the things I'm looking for. So those are my variables. So I'm just going to write to myself, I'm going to let X be the number of children that entered the park, and I'm going to let Y be the number of adults that entered the park. Any questions there? Okay, now I'm going to start with this one. I think this one's simpler. On any day, on a certain day, there were 268 people who entered it. Well, who were those people that entered it? Well, it would be all of the children and all of the adults. I'm about to sneeze, sorry. So the 268 people that entered the park would be all of the children and all of the adults combined together. So I could just say, if I take the number of children and I add the number of adults, it has to equal 268 total. Then the second one's going to have to deal with prices. So I know in total they made $1,198. Okay, well, how did they make that money? Well, if there were X children that entered the park, they made $2.50 off of every one of those. So $2.50 times X, that gives me the money collected from children's tickets. And then similarly, if there were Y adults that entered the park, they made $5.80 off of each of those. So they made $5.80 times the number of adults. That's the amount of money they made from adults. And in total, this has to equal $1,198. Questions there? Okay, and so once I have this set up like this, you can solve it however you would like. If you want to do substitution, you could. If you want to do elimination, you could. I'm going to guess most of you guys are going to choose put it in a matrix and do reduced row echelon form. That's my guess. You can do that too. This time the matrix is going to be a 2 by 3 matrix, right? And you can just enter that in, hit reduced row echelon form, and it will spit it out at you. I might actually choose that this time because I don't really like those decimals. So I've got a matrix that's going to be a 2 by 3. It's got 1, 1, 268, 250, 580, 1198. Quit, matrix, math, reduce row echelon, matrix, pick the one that you plugged in. And so I found my matrix was 1, 0, 108, 0, 1, 160. This tells me what? The X value needs to be 108. So children's tickets was 108. And then adults tickets was $160. I don't know why these adults are going to theme parks, acting like it's for them. Okay, what were your equations on the first one? X plus y equals 10. So x is the number of nickels. Y is the number of dimes. So in total, if I add all of my nickels and dimes together, I should have 10 coins. Okay. And then what's the second one? That will work. Did anybody do a different equation here? There's another one that will work. This one's fine if everyone did this one.
Can you do like 0.05 x plus
0.1,
equals
0.8, same thing.
Yeah, I tried to do that, but I didn't put 0.8, and I was so confused.
Yep, you'd have to put a 0.8. If you turn them all into like what you think of cents as looking like with money, that will work too. Okay, questions here? Is it 6 times 4 nickels? Okay. Have we already done the second one? Tried to? Is that what I heard? So are you ready for me to go over it then? Is that the consensus? Okay. A coffee distributor plans to mix some Queen City coffee that is $10 per pound with some Kenya coffee that is $14 per pound. In total, they're going to use 90 pounds of new coffee that will sell for $11.78 per pound. How many pounds of each kind of coffee should they mix round to the nearest pound? First thing, identify what are the two variables, the two things I'm looking for. How many pounds of Queen City and how many pounds of Kenya coffee am I going to use? So I'm going to let X be equal to the pounds of Queen City. And I'm going to let Y be equal to the pounds of Kenya coffee. So my variables are actually representing the number of pounds of each type of coffee. So now let's look at the numbers I underlined. So the prices, I always do the prices second. Because to me the price one messes me up most of the time. So let's look at here. They're creating 90 pounds total. So what equation could I write knowing that there should be 90 pounds total? That's it. So if I take the pounds of Queen City plus the pounds of Kenya, that should be equal to 90. To be okay there. Okay, the second one has to do with prices. So it tells me normally Queen City coffee is $10 a pound. Kenya coffee is $14 per pound. So I think you guys probably started making the equation correctly. What was your natural instinct for what to do there? Okay, that is what we want to do. So this is how many pounds of Kenya coffee I'm using. So say if I was using 30 pounds here of Kenya coffee, then I would do 10 times 30 to be how much am I paying in total for Kenya coffee, right? This is the total price of Kenya coffee here. Or sorry, Queen City coffee. I'm backwards, ain't I? This is the total price of Queen City coffee, 10 times X. This is the total price of Kenya coffee. And that would be, if I add those together, that will tell me how much am I going to have to pay for 90 pounds of this mixture. That's one option. You could do 90 times 1178, if that makes sense to you, to get the total price. Or you could divide this by 90. And that's the same idea, right? Dividing this by 90 means I'm finding the average price for those 90 pounds. So either one of those will work. I think the better looking way to do it is, like you guys said, 90 times 1178. Okay, what were our equations on the top one? Okay, so that means my guess is X is the amount of interest earned in a 6% savings account. So the interest earned from 6%, and Y is the interest earned from 10%. And so that means the total amount of interest he makes between the two is $52.36. That is not going to be correct. Because that's not what X and Y are supposed to be. What are X and Y supposed to be here? How much did he invest at each rate? So what do my X and Y represent? Yeah, exactly. Did you write down what they represent at the beginning?
No, that wasn't.
You didn't write that? X should be the money invested at 6%. Y is the money invested at 10%. Does anybody have an equation they think would work?
106x plus 0.1y equals 1,736.
That is the first one. Because X represents what? How much money I'm investing at 6%. So think of that as just like whenever you leave a tip or whenever they charge tax on something. So if I invested $100 and I'm making 6% on that, how much is my interest going to be? $100 times 0.06 means I'm earning $6 on that 100. So this is the money earned in interest plus this is the money earned in interest at 10%. So this is the total amount of interest has to equal 5,236. Does that kind of make sense? Do it kind of... Yeah, sounds good. You just keep pressing on. Okay, good. Does anybody see another equation?
Is it 0.16 equals 2x plus y?
No. But you've got some good parts in there.
2x plus y?
Yeah. So where did you get the 0.16 from? You just added the percentages together and went for it? Okay. The other thing that is important here is he puts twice as much money in his low risk account. So the amount of money he invests at 6% is double what he invests at 10%. So again, this is the one that I get confused the most. So I have to think, which one of these numbers is bigger? X or Y? X is bigger because he put more in at 6%. So if X is bigger and it's double Y, then X equals 2 times Y. I have to take the smaller number and double it to get the bigger number. See how I thought through that? My natural instinct is to say 2X equals Y. But I have to think through that every time, just like the way I told you out loud. Which one's the bigger number? So if I double the smaller one, it will equal the bigger one. Could you put this in your matrix as is? It doesn't work like this. Why not? Here, your X and Y are on the left, and your constant is on the right. You have to make this one look the same way. So like I would move the 2Y over and make it become negative. So we could write this as X minus 2Y equals 0. And now then if I was going to use reduced row echelon form, these are the coefficients I would put in this order. Okay, so so this is kind of a different setup. Or we're trying to figure out which of these is a better deal. Which is basically how my brain works at all times. What a shame. So what are the two things I'm looking for? Or what are the two things that I don't know? The minutes that I'm using each plan on. Right, so I'm going to let X represent the minutes on plan 1 and Y be the minutes on plan 2. Nope, that's wrong. As I was reading it some more, I disagree. I'm going to let X be the minutes I'm talking on the phone. What's the other thing I don't know? If you read that problem again, I had to read it a second time. The cost. Those are the two things that are important to me. The cost of the plan and the minutes I'm using my phone. So the first plan is 25 cents per minute. So what's that equation look like? So y equals, so the cost is 25 cents for every minute. So if I talk for 4 minutes, 0.25 times 4 is $1. So I'm charged $1. Does that make sense? What about the second plan? It is, the cost is 12 cents for every minute, plus a flat rate, right? Plus a monthly fee. So I'm paying $34.95 regardless. So which plan starts off cheaper if I don't use my phone much? This one's cheaper initially, right? If I talk for 4 minutes in a month, it's just going to cost me $1. Or if I talk 4 minutes here, I'm still paying $35 to have the phone, and then 12 cents for those 4 minutes. So if I'm going to be on the phone just a little bit, this one is going to be the better deal. If I'm on the phone a bunch, this one may turn into the better deal, but how much do I have to be on the phone for that to turn into the better deal? So we would need to solve. So for me, personally, I would not put those in a matrix, because what do they look like right now? Yeah, they look like slope-intercept form to me. So you could use substitution, that's fine, but if I'm going to use my calculator, I'm going to graph these as y equals and find the point of intersection. Right? It's where?
139.8 minutes.
That's the x value? How did you do it? Did you do
I set them equal to each other. I did 34.95.
a substitution? Because you're saying y is 0.25x, and you're taking this and plugging it in for this y.
I did
Same idea.
34.95 divided by 0.25.
I did 34.95 divided by 0.13,
That would be it.
and I got $268.84 or 85 cents.
You got x equals, right? X equals what?
$268.85.
Okay, but it's not money. Because what's x talking about? The minutes that you have to talk. So if you talk 268.85 minutes, which is a little over 4 hours, right? So between 4 and 5 hours.
139.8 is just how much.
Is that the y value?
It's whenever 25 cents per minute equals 34.95.
Okay, but this one is not a flat rate of $34.95, because this one also gets charged per minute. You see what I'm saying?
Yeah.
If it was a flat rate of $34.95, then that could work. But if you spent so many minutes here, that's going to make this price also go up. Yeah, so you would have to do either some kind of substitution. You have to do some kind of. You could get them x's on the other side and put it in reduced row echelon form. Like, that's not wrong. It's just I've trained myself on these kind of problems. I think about where the two lines intersect. I know one of them starting off cheaper has a higher slope. The other one starts off higher y-intercept, but it's a flatter line. And I'm just looking for at what point in time is their cost equal. Right? That's just how my brain works on this kind of problem, especially when they're already in slope intercept form. God, did not realize it was already time.